Hi, my name is Oleg, and I'm with the developer success team at Docker. I'm super thrilled to welcome you to the first episode of our video series about Docker and AI. This is a podcast-like thing. We're gonna look at technology. We're gonna look at AI. We're gonna talk to people who build and use AI and other Docker products in combinations, in isolation, separately by themselves, at the companies, in all flavors, combinations, and styles. And hopefully we're going to learn things. We're going to uncover maybe a little deeper look how it works and what does it mean to actually build things that make sense with those rather than looking at the superficial demos and hello worlds. It's going to be super, super interesting. So join us, follow us on the socials, and let's get started. We have in our virtual studio Michael Irwin as a guest. Michael is the principal engineer at the DevRel team at Docker. And today we're going to talk about WeAreDevelopers conference and what Docker announced and what are the new products and everything around that. Michael, welcome. How are you doing?
I'm doing great. And how about yourself?
I'm pretty well. Where in the world are you joining us from?
I am joining from the East Coast in the U.S. I'm in the state of Virginia. So for those that may not be quite as familiar, it's about halfway up the East Coast and joining from the Appalachian Mountains. It's a nice, beautiful day out today. And yeah.
Excellent. Right. So just a week ago, you barely managed to overcome jet lag. Just a week ago, you were in Berlin for WeAreDevelopers conference. Can you maybe introduce what Docker did at WeAreDevelopers and maybe what did you do there and give us some context. What are we talking about?
Absolutely. So for those who are not familiar, WeAreDevelopers is basically Europe's largest developer first conference. It's a really fun conference. There's we see developers that are just getting started with their journey. And they're like, hey, I just built my first website last week kind of thing, to those that have been experienced for many, many years. And so it's fun to go to this conference and interact and hang out with developers. And so Docker was there to, one, connect with the community and to share a lot of the new things that we've been working on. And we'll dive into some of these deeper. But the quick answer is, Docker's been doing a lot in adding support for agentic applications. We want developers to be able to use the same tools and the same processes, but now with this new stack. But we recognize that we had to evolve the tooling a little bit to make it work with models and MCP servers and tools and all these different things that this new stack needs. And so we've been doing that over the last couple of months, and we were excited to share that with everybody at the conference. At the conference, I did quite a few different things. I was working in our booth. We had actually a very large booth this time. And in the booth, we had lightning talks that we ran each hour. We had some demos that were going on. We had quite a few different things, activities. We were in like screen printing T-shirts. And I was impressed with how long the lines were just to get T-shirts. Everybody loves their swag. But also at the conference, I also put together and ran a workshop that we had about 40 attendees that exposed and hands-on with these new agentic compose features and capabilities. So yeah, quite a few different things going on at the conference.
Right. So you mentioned a number of things. Let's take them one by one. Let's talk first maybe about maybe Compose for agents. So I know Docker Compose, right? It's a YAML file that allows me to describe my services and configuration relationship between services. How does it fit into the sort of agentic applications? What is an agentic application? Like, what does it need? And give me the rundown.
Yeah, so first off, let's start with defining GenAI in the first place. So GenAI is basically using models to create new output, new content based on unexpected inputs. And so those inputs could be unstructured text. It could be like, most of us probably use ChatGPT or Claude Desktop or something like that. And, people are just typing in whatever it is that they want to do. And so models can understand this natural language and then produce output. Okay, so that's kind of the GenAI space. Agentic applications kind of take that a step beyond, where now agentic applications are starting to do reasoning and thinking and using tools to maybe go and fetch additional context or go perform additional functions. And so as we look at the compose file, it's like, well, how do you define a model in the compose file? And how do you then connect it to your application? How does the app know how to connect to that model? Same thing with tools. How do we expose tools? How does the application know how to connect to those tools and discover the tools that are available? So that's the evolution that we provided to the compose specification to support basically models, tools, and then the custom code that glues it all together.
Right. Do you have an example? Can we look at something like?
Sure. Let's do something. And actually, funny enough, just over the last 2 days, we had a internal hackathon at Docker, and so I'm going to show a little bit of the hack that I was putting together here. And so let me pull up my screen here. So this particular application, actually, maybe for some context on what this app is, I was looking at a lot of our sample apps and tutorials and workshops and things that we have here at Docker, and we've got quite a few of them out there. And for whatever reason, we've got this interesting trend where folks they submit PRs to basically say, hey, here's what I did in the workshop. Here's the Docker file that I made or the changes to the website. And we're super excited that folks are doing the materials. But like if we accept this PR back, well, then it's going to inhibit the ability for the next person to be able to do the work. And so we're looking like, is there a way that we can automate basically an analysis of the PR and be able to do something with it? So I'll just kind of pull up the whole architecture here. So basically we're going to respond to a webhook from a PR that then the application is going to use 3 different agents to analyze the PR and basically say, hey, does this PR kind of solve the usage of, or is a PR indicative of what a student would be doing as they go through this? Let's generate a comment, and then let's add the comment and close the PR. So that's kind of the context here. So going back, I've got my application. Okay, and you'll see that this application needs a couple different models. So in this case, it's using a Qwen 3 model, it's using a Gem 3 model, and those are defined down here. Okay, so in this particular case, the Gemma 3 model, I'm going to pull from Docker Hub, and it's using the AI Gemma 3 and the specific version of this. And actually, just as of yesterday, the VS Code extension was updated so that I can actually click directly on this link and get additional details about the model here.
Nice, sweet. I love those little details in the integrations.
I know, it's so nice. It makes it so much easier. Okay, maybe these aren't the right parameters that I want. Okay, now it's easy for me to go and look at additional tags and whatnot.
Run me through the letters there. Like, so this is the LLM, right? So large language models. It is Gemma 3. And then what are the 4B-F16 there?
Yeah, so the first part here is the number of parameters. You can almost think of it as the size of the model. So the more parameters, the larger the model, the smarter, the more capable it's going to be. But also the more machine resources it's going to use. So that's kind of the balancing act of what's good enough to be able to work, but also small enough to still fit on my machine and work. So in this case, I found that the 4 billion parameter was a good spot for me here. The F16 and also this Q4_0, these represent quantization, which you can almost think of it when looking at a model, it's just a collection of numbers. And so what the quantization is represented is basically how many bits are being used for those numbers. And so the more bits, the more accurate the model is going to behave. When you start using fewer bits, it's going to start summarizing a little bit more, and it may not be quite as accurate. But again, it's a trade-off, because then smaller bits means it's going to use less resources. It's going to be a smaller model. It's going to be faster to download and run, et cetera. So again, it's something that folks will have to experiment a little bit with, because I can have lots of parameters, but then have very small quantization, and it may or may not work the way that I want it to.
Right, I see. And so for the Qwen model, you have more parameters, but lower quantization, right? So instead of floating points, you have some sort of short integers there.
Yeah.
So it's going to be a little bit more all over the place, chaotic, and maybe less precise in the outputs. There is a question in chat about from Andy. There is a concept floating around of minimal viable model, where you build applications using the smallest models that you can do, that can do a good job for your particular thing that you need, especially if you're using multi-model applications. Can you elaborate? How do you pick a model? Yeah. What is the smallest viable model, and where are we going as the ecosystem?
Yeah, and actually, while we're doing that, here, I will pull up my browser here. So, for example, this is that Gemma 3 model. And if we look at the Gemma 3 model, we can see that there's a lot of different variants between the parameters and also the quantization as well. And you can see that for each of these, the size is going to vary quite a bit. So, for example, this one that I was using, the 4 billion floating 16, it's a just over 7 gigs to download, and then it takes 8.5 gigs of VRAM. So again, it's a fairly large model, yet I could probably also experiment and say, well, hey, can I use the 1 billion and maybe floating 16? And now, again, it goes from 8.5 gigs of VRAM to 2.5. So the idea with minimal viable model is you want to find the minimal viable model, the one that's going to be small enough to accomplish the tasks that your application needs to be done. Because if you're using a larger model than what you need, that's going to take more time to download. It's going to take more resources to load. And especially, since it was called out here, if you're using multiple models for your application, every time you're having to swap the model, that's additional context switching of having to unload the previous model, load the new model, get it loaded into memory, et cetera, use it. All that takes time. And so the smaller the model, once you kind of find that sweet spot, then things are going to at least run a little bit faster than they would otherwise if you're using models that are too large for what your application really needs.
Right. Yeah, the Docker model runner, this is the limitation that we currently have with the scheduler, right? When you have a model in memory loaded and you want to access another model, there's a very straightforward algorithm currently. So using one model at a time is best. If you have a ton of resources, maybe you can have a couple of models, which you would maybe spend on an embedding model and an inference model, and have both in memory. Okay, so minimal viable model, I understand. Personal advice from you. When you choose models, do you try to stick to the same sort of family of models from the whole zoo, or are you, every time you have a task, you're like, okay, I need to evaluate my Quents, my Mistral models, my Gemmas, my other stuff, right? What's your rule of thumb?
Yeah, that's a good question. So for each of these models, like each model is good at certain tasks. So for example, and we try to put that on the cards for each of the models. So for example, this Gemma 3 model, okay, it tells me, okay, this model is good for text generation, chatbots, conversational AI, text summarization, et cetera. And so kind of like here's the anticipated use cases for this particular model, where let's go over to the Qwen 3 model. The Qwen 3 model designed top-tier performance in coding, math, reasoning, and language tasks. So maybe if I have an application that needs to do more reasoning of thinking, or maybe it's going to be a multi-step execution, the Qwen 3 model is going to be a little bit better. So again, it takes a little bit of experimenting and learning. Okay, what are the different models? What are they good at? What are they not good at? And then using that. I do find that, for example, this particular example app, comment generation, I've used the Gemma 3 model quite a few times, and I'm pretty happy with its performance. I do find myself going back to it quite often. But again, some people may say, well, I want to use Llama for this. Great. Again, you've got the choice. You've got that flexibility.
Right. Okay. So we have this model block in Compose, and it's a top-level block.
Yep.
Can you just a month ago, I saw that we are doing a similar thing, but with the provider spec, provider component, where the Compose providers are the ability for Compose to specify sort of any local executable for the type, right? And then have Compose kind of sort of ingest that into the lifecycle of the larger deployment. And that was a very flexible approach. Mm-hmm. You could run not just models, but you could run, I don't know, like a telepresence local binary to deploy some stuff into your Kubernetes clusters or any other binaries. Why no models are the top level spec?
Yeah, great question. So first off, I want to make it clear that the provider support is not going away, or the model support is deprecated in favor of the new top level models, but the provider support in Compose to be able to support, like you were talking about, telepresence or other kind of mechanisms, that provider support is as part of Compose now. It's not going away. So those capabilities will still exist. I know I'm excited about that as well too. I think it opens up a lot of really, really cool possibilities and opportunities. So why did we make this change?
I wanted to make play a sound
Go for it.
on my local machine when everything is done. I'm going to run it as a service, depend on everything else, and when it's done, it's going to play a sound. Bing!
That's right.
I think it's doable.
Yep. So the reason that we migrated from this, okay, to a formalized top level structure is because it gives a little bit of concrete structure. And especially as we're looking to integrate with other clouds. So for example, we also announced that WeAreDevelopers, the Google Cloud support, or I guess Google technically announced it, but now you can do a G Cloud Compose up basically. I know that the command looks a little bit different, but in order to support that, it needed a little bit more structured specification because the provider syntax is very flexible, which works really well for providers, but we needed something a little bit more concrete for other cloud vendors to be able to integrate and use here. Some of the other advantages that this brings, though, is, I'll just go ahead and delete that, is when we've got this top level and when we plug it into the app itself, it gives additional capabilities now, where now I can actually define and say, hey, for this Quinn 3 model, what is the endpoint? What is the environment variable that I want to expose the endpoint with? Where the provider specification was always just going to use I guess I'll bring it back now. It was going to use the name of the service and then underscore URL underscore model. Like you didn't have any customization opportunities. And we wanted to be able to allow folks to say, hey, maybe I just want OpenAI based URL. There was no way for them to be able to specify that through the provider specification. But now you can completely control how those environment variables are exposed.
So we have a stronger schema.
Yep.
Right. And that helps us to control things better. So here we are, am I right that we are injecting the Qwen endpoint variable into the environment variable called OpenAI base URL analyzer. So whatever service we're defining here, it can go read that environment variable and the value will be the Qwen's endpoint.
That's correct.
Right. Oh, perfect. So like this allows me to orchestrate. This allows me to have like a actually tightly and coherent schema. I love this. Yep. So there is a question about Compose Bridge from Sergey in the chat. I think we're going to talk about Compose Bridge slightly later in details, but is this already supported by Compose Bridge to convert into Kubernetes?
Not yet.
Okay.
Coming soon.
I assume so. WeAreDevelopers was just last week, so people first need to get over the jet lag, then implement additional things.
Absolutely. Yep.
Okay, so now your Compose file, right? You have the models, so that's the brain of the thing. You have the services, which are agentic applications, everything that is normal, right? Yep. Like this is your app, you can build it, you can run a predefined Docker image. The third thing that you mentioned, agentic applications needs are tools.
Yes.
So how does tools plug into this thing?
Yeah, great question. So one of the other things that we announced at WeAreDevelopers is that we've open sourced a new tool, a new capability. So folks that might have heard about the Docker MCP toolkit and catalog and things that we've been plugging into Docker Desktop. Well, the MCP Gateway, the MCP proxy that we're basically using within Docker Desktop, we've now extracted out and it's its own standalone open source project. And so what that allows me to do is here in my Compose file now, I can just say, hey, I want to run the Docker MCP Gateway, and then I can fully configure it to say, hey, these are the servers that I want to use. In this case, this is using the GitHub official MCP server. And then even then, like this GitHub official MCP server exposes 71, 72, somewhere around there, a lot of tools. That's a lot of context that my application is going to have to send to the model every single time. But now I can filter out and say, actually, hey, I only want to allow these 8 tools that my application is actually going to use. So again, the MCP Gateway allows me to specify, here's the MCP servers that I need. It's going to run a container. I can inject secrets. So in this case, it's going to be my GitHub personal access token. And then once this is running, it's using the SSE protocol. I can just, again, plug that into my application and just say, hey, you're going to find your MCP gateway here, and then my app is just going to create an MCP client, connect to that MCP server, get the tools from there, and everything just works.
Right. So, okay, let me rephrase back.
Yep.
Did I understand this well? Right. So it's an open source project with the publicly available Docker images. So Docker/MCP Gateway is a Docker image that you can use to instantiate a container with the gateway that can act as your MCP server, sort of the toolkit that you bind here to be an SSE MCP server.
Yep.
And you can specify which actual end user MCP servers you want to use. Yep. GitHub official, filter the tools, which is super, super cool. Yeah. I've seen people complain that MCP servers expose so much, and it's not just GitHub. Like, for example, Puppeteer, right, exposes around 20 tools, I think. And what you usually use it for is to open pages and click on elements. So you need 2. And this way I can limit, how do we also run those MCP servers in an SSE mode and connect, or how is that fits into picture? And what is this use API socket thing?
Yeah. All right. So let's start with that first one. So when this MCP gateway starts, okay, I'm specifying I want this GitHub official server. That's going to run containerized, and that's actually why I'm using the API socket. I'll come back to this in just a second. But so the MCP gateway is going to basically manage the life cycle of the containerized MCP server. In this case, again, GitHub official. The cool thing, though, is that the MCP gateway isn't going to just keep it up and running forever. Okay, it's going to basically allow it to scale down to 0. So when I'm not actually going to use that MCP server, it's not going to be running. Okay, so I'm not going to have all these additional resources being used, except for when I actually need them. So if my application decides, hey, I need to get a pull request diff, okay, great. The model will send that. The app will then delegate to the MCP gateway. That at that point in time is when the MCP gateway will actually spin up the container and say, hey, now invoke this tool. So it's only running the container when it needs to run. Okay. Now, because of that, yes, it needs access to the Docker socket. And so one of the things that we've added is actually this new use API socket flag. And this is doing 2 things. Okay, one, it's mounting the Docker socket, which we've probably seen, quite a few folks do something like this, and putting the Docker socket in. So it's doing that. But before it does that, it's also creating basically registry credentials and injecting that into the container as well. So if I'm in an organization, for example, that requires authentication for every request, okay, well, now when the image is going to be pulled, there's a credential to be able to do that now. And so that use API socket is doing 2 things. Again, it's mounting the socket, but also providing the credentials that are needed to actually go fetch those images, which does open up the opportunity to be able to have private registries, or MCP servers coming from private registries and whatnot in the future.
That is awesome. And I assume we're gonna add an easier time for in-house catalogs and everything. That is not yet in, right?
Correct. So there is a mechanism. So in fact, actually, maybe I'll just show this real quick. If I do a Docker run, Docker MCP Gateway, I can run just --help, and I can see all the options that are available here. And there is an option to specify your own catalog, and you can see where the default catalog comes from. So technically, yes, you can go and create your own catalog, and you can follow the schema of this catalog YAML file. You can create your own. It's kind of a messy process. We're still working on making that better. Again, we just released this first round of features last week. But yes, you will be able to define your own catalog, put your own MCP servers, etc. Expect the tooling to get better around that here very soon.
This is awesome. This actually is fantastic. Look, so the gateway it isolates the same way MCP toolkit in the Docker desktop. The gateway isolates those MCP servers and can pass the secrets to the particular ones that are allow listed, right? And then it blocks the network if necessary, right? You can configure CPU if you want a bigger compute for a particular MCP server calculation. This is awesome. There is a lot here, but hopefully this is very, very useful, and hopefully people will start realizing that this is a convenient way to encapsulate their MCP server deployments.
Yeah, absolutely. So again, kind of wrapping it up again, let me shorten this. Now with the compose file, recognizing that agentic applications need models, tools, and custom code. There's your model. Let me get rid of the provider here. There's the models. I can inject those into my application. Okay. I can define the tools that my application needs and just configure where do I access those tools. And then the custom code, this is just a normal container. Okay. And this particular app, it's using the Master framework. But yeah, we announced, or with the announcement last week, we provided a collection of example apps written in a wide variety of different frameworks: Agno, ADK, Vercel, Spring AI, and so on. Yeah, here. We'll put it down in the description as well too. But I'll switch over to my browser here. So it's in GitHub Docker/Compose for agents, and you can see that there's each of these folders are basically a separate example application written in a different framework.
Oh, I see. So QueryAI,
Yep.
LangChain, Go, LangGraph, Spring AI, Vercel, I assume AI SDK. This is so cool. Yeah, and all those examples, right? It boils down. You go into this repository, you go into this directory, and you like run compose file.
Yep.
So okay, I can see that. Building agents is now composing building blocks that are compose YAML. And because I can run multiple compose files in the command, right? I can do like docker compose minus F1 file minus F another file. I can actually have different agents kind of sort of come up together, but all of them be specified in isolation of their own YAML.
Yeah, and actually, as an example, one of these, we've got, so there's a base compose file, and then there's a couple others, whether you're using a Docker model runner, because I think actually the default for this one is using OpenAI directly. And it's like, okay, cool. Again, let's show examples of how it's easy to swap out. Maybe sometimes you want to use local models. Maybe sometimes you don't. And again, show how easy it is to be able to swap all that configuration out. Here's an override that uses the Docker model runner, and even another one that uses Docker offload, which we haven't had a chance to talk about yet. So
that was going to be my next question. Quick question in the chat from Julius.
Okay.
Can I link multiple models to a single service? Which I assume you can. You just bind it to different environment vars.
So actually, this example here, I'm doing exactly that. I've got both Quinn 3 and Gemma 3, and yeah, I specified different endpoints or different environment variables, just so then it makes it pretty easy. So in the code itself, for example, actually, let me go back up here. Where is it? Okay, where I create the OpenAI client, I'm basically plugging in, here's the base URL, and it's going to use that environment variable. So each of my different agents are just looking at different environment variable names.
Right. So it's the same under the hood. This is the same endpoint, right? This is Docker model runner endpoint, and is just the model names are different when you submit your request there.
Yep.
Very, very cool. Okay, so tell me about this offload. How do I assume you can run this. I assume your machine will struggle. Well, maybe not your personal machine because you have a beast of a MacBook, but my machine will struggle, or a normal developer laptop will definitely not be running very powerful models. So talk to me, what is this offload?
Yeah, so what offload is a new capability that again, we just announced last week at WeAreDevelopers. And the idea is, I need additional resources. My machine may not have a strong GPU. I may not have a lot of additional memory. But with offload, I could basically just go in here, flip this toggle up here, and now, in fact, maybe we'll just go ahead and do it. What's going to happen is you'll see that the UI changes here, but now all my containers, all my models, basically everything is now going to be using resources out in the cloud. And that's as easy as it is. And so now I can see, I have no containers running, but the next container that I run will start up in the cloud. But it still gives the impression and still feels as if it's local. So all the port bindings and volume mounts and everything else that I would probably be doing with a normal container-based workflow, all that still just works. All just with the flip of a toggle there.
Can I use this setup to run my normal containers?
Absolutely.
and I can access them the same from localhost from my machine.
Yep.
Can I run compose files?
Absolutely. Yep.
Do you have a powerful GPU in the cloud?
Yeah. So, I don't remember the exact model, but it's a pretty beefy NVIDIA GPU that we've got running in the cloud there. And again, it can run some pretty high end models there.
Right. So it's an NVIDIA L4 with 24 gigs of VRAM. You can run, I think, very conveniently, you can run models up to like 30-ish billion parameters at the moderate quantizations. Depends a little bit, of course, on the context size that you configure, because if you need like the bigger the model, the longer the context size, the more memory the context size will eat, and then the more you need to balance it a little bit. But you can do very sophisticated things there, and I've seen some setups with the more powerful GPUs there. So hopefully, one day we're gonna have the shapes for the machines being selectable. So if you want to run your actual proper like machine learning workloads there, you can get a beefier cloud worker as well. But I can run my normal things here, right? Like if I would like to run my test containers tests and just run a bunch of Oracle databases. I can get the worker without GPU maybe, and then just run it. Okay, cool.
Yeah, so
it's a cloud service. Sorry, it's a paid service, right?
Yes. So
how
yes,
how does it work? Is it pay as you go? Do I need to sell my soul for this?
No, it's actually not too bad. And I'll switch over to the product page here. So this is and we'll put this down in the links in the description and whatnot as well too. But the way that the pricing works, if we scroll down, okay, so if you sign up for the beta right now, we're giving folks 300 free GPU minutes. And so then it says after the credits expire, usage is priced at 1.5 cents per GPU minute. And so that's it. And you could basically pay for a collection of minutes, and then you have this basically credits that are available to you. And then as you're using offload, it's just going to be consuming those credits.
Right. That's not too bad. I think this is very comparable to various pay-as-you-go services. So this is nice. I really, really like the user experience where I just keep using my Docker primitives, keep just running things from my IDE, and it works. Right. Awesome. This is fantastic. I think we are currently, if you have questions, this is the right time to ask them. The main announcements, Michael enumerated here. So we have a question from Sergey. What are current offload limitations, and do we have future plans on that topic?
Yeah, so one of the things, and actually I got this question a couple times at the conference. It's like, okay, is it a binary switch in the sense of, okay, either I was running everything locally and now I'm running everything in the cloud. Can I do kind of hybrid setup where maybe I want to keep my containers running locally and run just the model in the cloud? Is that use case supported? As of today, again, we just announced version 0 of this. It is binary. So when you switch to enable offload, everything's going to run out in the cloud. So all the containers, all the models, everything's going to start in those resources. We have heard that feedback. It's something that we're interested in and looking at. Of course, don't have any timelines to announce around that, but it is use cases that we are thinking about as well too.
That is awesome. Can I run Windows containers there?
No, that's a great question. So yep, it's just Linux environments, and so
it's a cloud.
Linux containers.
It's a cloud. So it's a Linux machine, right? Very good. And I assume this is also the AMD machine, right? So like it's not ARM. So
That's correct.
if my images were built locally on a Mac for ARM, it might conflict, but there are tools, I assume, where I can just build for both platforms and run them, right?
Yeah. So, and actually, that's a great observation there. So, when I am using offload, when I do a Docker build, it's actually going to be leveraging a lot of the same infrastructure that we use for Docker Build Cloud. So again, that's kind of behind the scenes details there. But so if you do a compose file, or in fact, going back to this compose file that I had here, this is going to build a container image to use for development. If I were to spin this up, it's going to build this out in the cloud, and use the right architectures and everything that's needed for the runtime there, the image will be there in that offload instance, and everything will just work. So yes, if you've got images that you built locally on your machine, then you switch to offload, those local images aren't going to be there on the offload instance. You're going to have to basically rebuild them there in that context.
Right. Do I need to have internet to use Docker offload?
Yeah, great question. So since this is connected to cloud instances, there's basically an SSH tunnel and lots of other details. You will have to have internet access. But I will say, so for example, actually, I was running a workshop at the conference, like I mentioned earlier. The amount of internet that you need is much less than what you would need if you were having to download those models and everything locally. So the big advantage is you're basically just having the small tunnel to connect to the remote instance, but then that remote instance has crazy fast bandwidth and speeds. And so it's going to be able to download models and images and install packages or whatever else your container image builds might need. It's going to be able to do those things much faster out in the cloud. So yes, you do need to have a persistent internet connection, but it doesn't need a lot of bandwidth there.
Excellent. Last question from me. Can I use this in CI?
Yeah, great question. Still working on that. And there's aspects of it. In fact, a lot of the kind of back-end infrastructure is very similar to it's actually using a lot of the same infrastructure that Test Containers Cloud and whatnot we're using. So we're working on basically streamlining a lot of these services and products together into this offload capability. So the offload tooling, that the CLI and things that are needed to actually connect and use that in CLI or in your CI pipelines isn't there yet, but it's coming very soon.
Right. So then I will be able to use this in the full extent of my DevOps pipeline until production, right? And then in production, my compose will be picked up by cloud providers and run the same compose. So it's going to be a candy of a software development experience.
And that's a great call out. So offload is not intended to run your workloads for production. Again, that's actually part of the reason why we picked the name offload. We're basically just offloading development and testing and even building to the cloud. But this is not intended to be here's where you run things for production. It's very much here's my development environment. And even as of right now, like if I'm running my containers in offload, I can't have a URL that I can share to you. So that you can access it.
I know.
It's a personalized experience.
I have a hack for that. You just run a Cloudflare tunnel container and you expose it to the whole internet or ngrok or something like this. We are experienced in the ways of shadow IT here. Right. On this funny yet slightly controversial note, we're going to start wrapping up. Thank you so much, Michael, for your insight. So just to recap, we talked about Docker announcements at WeAreDevelopers, namely how we would envision people using Compose for building their agentic applications, incorporating the config for their agentic loop application as a service in Compose, models as brains for the applications, and the tooling with the recently open sourced MCP Gateway, which is similar to MCP Toolkit in the Docker desktop, but as a Docker image, so you can run it anywhere, including your production setups. You can get examples of those applications in the GitHub repository, Docker/Compose for Agents. Go check it out. Find your favorite agentic frameworks there. If it's not there, send us pull requests for better examples. And if you don't have capacity to run those heavier machine learning LLM models on your laptop, you can check out Docker Offload, which is intended for offloading compute-intensive computations, possibly including the GPU access in the worker, so you can run AI workloads there in the cloud from the convenience of your Docker user experience. So I think those are cool announcements. As you said, there are some, if you enroll into Docker Offload right now, you can get some free time to play with this compute platform. Do that. I think there is no downside in trying it out, and tell us all and every piece of feedback that you will encounter. I'm sure there are some rough edges here and there. There are some limitations for your particular use cases. They're bound to be. Docker ecosystem is more than 10 years old, so I'm sure anything that could have been implemented under the sun is implemented with various hacks and various corner cases. So we would love to learn about that. Other than that, happy hacking, happy building agentic applications. This was the first episode of the not yet named podcast around AI ecosystem tooling and application developers point of view. We had Michael Irwin from Docker here as the guest. Stay tuned for the next episode, which will be with Jacob Howard from Team AI Runtime. And we're going to talk about Docker Model Runner on Docker CE, how it runs, why it runs, how it's different from being built into Docker Desktop, how does it run in Kubernetes, what do you need to know, how to configure models, all the questions about why the scheduler there is not yet built done, and how did we build this. Bring all those questions. It's going to be happening very, very soon. Subscribe to all our socials. Follow us on GitHub. I think this is it. Thank you so much. Until next time.
Thanks all.